Hello, fifth graders. Good morning. We're going to do a note card today. Hope you guys are well. I hope you had a great weekend. It turned out pretty nice in the weather on Sunday, which was great. And Saturday was a little rainy, but we had a nice weekend. My son had a couple of hockey games. My daughter had a soccer game. So we were kind of busy going from place to place. I had a hockey game as well. So lots of kind of like traveling around and kind of that type of stuff. And happy Mother's Day, by the way. So for all of you, I hope you said Happy Mother's Day to your moms, and treated them well this weekend. Gave them kind of like a little break, I hope. Um, but yeah, so anyway, here we go. We're going to do a note card today, area and perimeter. And we're going to do it pretty quick, and then I'm going to show you kind of the activity. I also want you finishing your tessellation today. So that's the other thing that I want you to work on. But let's talk about the note card. Area and perimeter is a bit of a review from earlier grades. You've probably been doing this for a while, but it's always good to have kind of like to come back to stuff and talk about it, make sure we understand it. So what I wanted to start with was this idea of like breaking this down into two sides and saying which is which. So the first thing we're going to talk about is what is perimeter, right? And I think actually, let's do this in purple. We started it in purple. So perimeter, right? And I want you to write this down. So if I write it down, I want you to write it down. Perimeter is the distance. Yeah, so we're going to say perimeter, the distance around a shape. All right. So the distance around the outside of a shape. The outside of a shape. All right, that's pretty simple, right? That's your definition. And a perimeter is always measured in like kind of like a linear distance, like feet. You'd measure it in feet. You'd measure it in. Let me write this down. You'd measure it in feet or centimeters or meters or inches, right? So I'm mixing up my different units here. Feet and inches are kind of go together. Centimeters, meters kind of go together. But you're measuring it in kind of like linear distance, which means it's just like a straight line measurement. So if you're measuring something in a perimeter, you're just talking about how far the distance around. And area, which we'll do in blue, area is going to be on this side of the page. We're going to say area, right? And I'll put a line down the middle. Area is the number of square units. So the number of see if I can fit it here, square units that fit inside a shape, right? And now the difference here is our units would be, let's say, like we'd say square feet or feet squared, or we could say centimeters squared, we could say meters squared, or we could say inches squared, right? And there's lots of options here, but basically we're always talking about a square. And you can tell I'm doing this on grid paper or on a graph on my whiteboard, so that's important. So area is the number of square units that fit inside. So one's the distance around the outside, the other is the number of square units that fit inside. All right, so I'm going to put a line down the center on these two things. We're going to look at both of them, right, in different ways and how they work. And then I also want to show you up here. Up here, I made this purple outline. That's our perimeter, right? So our perimeter, right here, this perimeter is if you measured along the outside, right? So this, if we measured all these sides, that would be perimeter. But our area over here would be the squares that fit inside. I'm looking at this box, right? It's the number of squares that we would fit inside, right? So this is our area. So if I was measuring the area of this one, I'd say, well, how many squares fit inside of this shape? And I'd count them all up. So that's my area. The area is always in square units. The perimeter is in just linear units. So if I was measuring this box, that's what we're talking about, right? So this is my area. This is my perimeter. I know they got them mixed up, but whatever. It's all right. You guys know what I'm talking about, I think. It's kind of review, right? All right, now let's practice that. A couple ways to get it. So let's go back to our area calculations. And for area, you often are talking about counting squares. So if I make a shape, and I'm just going to kind of draw a shape over here, and I'm going to make it look like this, and then I'm going to make it look like this, and then like this, and then like that. Okay. So that's a pretty funky shape, right? But we're going to talk about how do I find the actual area of that? Well, one way to do it is instead of doing any calculations, I'm just going to count the squares. So what you're going to do is I'm going to break this down into squares, right? And I'm going to say how many squares are there. And we're going to kind of call these are just square units at this point. So as I draw these squares into this thing, my area right here, so my area of this shape is, we're going to say, count the squares. Now there's always formulas for different things. Like these are different rectangles, so I could do formulas, but I'm just going to count them. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my area, my A on this shape is 13 square units. And that's how we do area of that. Now, if I want to do the area of let's do an area of a rectangle, right? I'm going to try another one. I'm just going to do an area of a rectangle. And I'm going to say the area of this one, I'm going to give you dimensions. This one is 2 by 3, right? So the area of a rectangle, I can find, let's go back to our gray, and we can say the area of a rectangle is area for a rectangle equals length times width. That dot means times, by the way. And that means in this case, we could say the length is 3 and the width is 2. So our area equals 6 square units, right? Or 6 units squared. And that's kind of how we do this. That's it. And if I wanted to, I can obviously, you guys see the pattern here, I think. We can kind of break this up like that. And now we've got our two different ways. Count the squares or use the formula. And this is only for a rectangle. Like this formula is only for a rectangle. Let's see if I can fit that in. Almost. Oh yeah, barely. Only for a rectangle. Let's put a little asterisk here, right? So this area right here, put a little asterisk. Only for a rectangle. All right, now let's talk about our perimeter. Let's do the same thing with perimeter. And I'm going to shrink myself. Whoop, tiny. All right, and we're going to go to purple. And we're going to draw the same shapes with perimeter. So for perimeter now, I'm going to take this one and I'm going to kind of like draw what I drew before, just so we're looking at the same types of shapes. Let me see, 2 there, go down 1, over 2, up, drawing this poorly. Sorry, guys. So this shape is not so pretty, but same deal. The idea of perimeter here, which we're going to say is P, so perimeter equals P, so perimeter, which is P equals, we add up all the sides, right? So now what I'm going to do is I'm going to go in and we're going to measure all the sides. So down here, this side, 3. This side, 3. This side, 1. This side, 1. That side, 3 again. And then we got a 2. We got a 1. And we have a 2. Now we've got all of our sides there. We're looking at it. I'm looking at the squares. You can see all the squares inside, but we're not concerned. We're only concerned about the distance around. It's like fencing, right? Like how far is it? So what I try to do is I pick a point and I say, all right, I'm going to go around my thing like in a certain direction. So I'm going to go this way and go clockwise around this thing and just add them all up. So the perimeter on this problem, I should maybe do it down here, but it's going to get messy up here. So my P, let's move that down. Sorry if you've already kind of gone there. Let's go down here and do my perimeter. Perimeter equals 3 plus 1 plus 1. So check, check, check. I've done all those. Plus 3 plus 2. And the reason I like doing it in order is that I see if I missed something. It's easy for me to go back and double check that I got them all. +1, +2, +3, and now I'm back where I started. So now I add all these up, and this is a pretty easy, these are easy numbers, so easy in your head is pretty easy. Like 3 and 1 is 4, +1 is 5, 5 and 3 is 8, 8 plus 2 is 10, 10 plus 1 is 11, 11 plus 2 is 13, 13 plus 3 is 16. So we're going to say this is 16 units. Now notice I didn't write square units because we're not talking about squares anymore. We're simply talking about the distance around the outside, right? So that's pretty much it for perimeter. We just add up all the sides. Now, when I have something, and I'm going to go up here and erase this P, and we can erase this perimeter, right? I don't really need that because we're talking about that. But now what I'm going to do is show you with that same rectangle. If we look at the rectangle and we draw something like, well, let's draw this one in red. If I draw one like I did below, I'm still on the, I got to change all this. As soon as I erase something, it makes me change everything. Kind of a pain. Okay, so I'm going to draw another shape, just like I did below, or just like I did for the area. And this shape is going to be, this same thing over here. We know that this side is 2, and we know that this side is 3. We're doing this based on all of the squares, right? Or based on not the squares, but the grid. And then if I know that that's 3, I know by transference that the bottom of the rectangle also has to be 3. And the other side over here also has to be 2. So now the perimeter of the red one, right? The perimeter equals, right? And what I can do is I can say 3, and I can start up here, 3 plus 2, right? Plus 3 plus 2, right? And I'm just basically adding up the 4 sides. And once again, I'm slamming these together in terms of the picture. So or in terms of these two things. But 3 plus 2 is 5. 3 plus 2 is 5 again. So we know the perimeter is 10 unit. So clearly the bigger shape has a much bigger perimeter, right? This one has a perimeter of 10. This one has a perimeter of 16. I'm actually a little surprised. I would think this one would actually be even bigger, but it looks like it's right. Yeah, it looks like we didn't miss anything. 3, 3, 2, 1, 2, 3, 1, 1. I think we're in good shape. All right, so that's the difference between area and perimeter. Hope you're kind of like understanding that. I think you know that from before. But now what I'd like you to do is I'm going to take a look at our next slide, and this is the stuff I'd like you to work on. I would like you to work on this as your practice problem today. I'd like you to look at these and think about which one do you think has the largest area? Which one do you think has the largest perimeter? And I'd like you to draw them on graph paper. If you have graph paper, draw them out. I think you should get graph paper, but you can trace them if you want to off the screen. I'll put this into an assignment, but your assignment today is to do that note card, but also to do these 4 problems. I want you to find the area and the perimeter for all 4. So your instructions are find area and perimeter for each one, okay? And show your work. So area and perimeter for each shape, okay? And these are all polygons, by the way. They're closed shapes. So because they're closed shapes, we could say they're each they're all polygons. Now, when you do that, I want you to think about like what makes something have a longer perimeter. Like what are the things that makes it have a long perimeter, and what makes something have a large area. So of these, if you look at them quickly or look at them with a little bit of study, like do you think, and maybe you guys can like discuss this before you start, discuss with your teacher which one do you think has the largest perimeter and why? Which one do you think has the largest area and why? And do the same thing with the shortest, the smallest. Which one has the smallest area and which one might have the smallest perimeter? They're not always going to be the same one. Now, clearly, the orange one looks pretty small compared to the others. But I'd like you to kind of take a look. Like, do you think this pink one or this blue one or the green one would have the largest perimeter? And I want you to figure out why that might be. Why do you think one is worse than the other? So see what you can do. But kind of compare and contrast. Count these up by squares. So remember, area is number of squares. So total squares, right? And perimeter is distance around the outside. So this is a distance thing. All right, I think I have to end this video before 15 minutes, so I better cut it right now. Bye, guys.